proof is of the product rule for differentiation. Proof that the derivative of a product, f of x times g of x, can be thought of as the first function times the derivative of the second plus the second function times the derivative of the first. And of course, because addition is commutative and multiplication is commutative, there's lots of other ways of saying this. Some textbooks like to differentiate the first times the second. Notice that that term is the same as this term. And then plus the first times the derivative of the second, which is certainly the same as this. Okay, how do we start? We are going to start with the definition of a derivative. So again, all proofs depend on definitions, axioms, or previously proved theorems. So we need to recall that the derivative of a function, u, ugly, with respect to x, is defined as a limit as h goes to 0 of whatever the function is, x plus h, minus whatever the function is as h goes to 0, h on the bottom. Okay, so this is sort of the definition of a derivative. We might have called this u prime of x. Okay. So we are now going to use that idea on this particular product. So let's see. By definition, the derivative with respect to x of f times g is a limit as h goes to 0. Okay, we have this difference quotient here. We have f of x plus h times g of x plus h minus f of x, g of x, and h is on the bottom. Okay, so we need to somehow show that this particular limit reduces down to this expression right here. That's the idea. If we can do that, just using limit theorems, some algebra, and prior definitions, then we will have proved what we want. Okay, so let's see. How might we do this? There's a number of ways of doing it. I like this approach. You take this limit as h goes to 0, f of x plus h times g of x plus h, and you subtract off this quantity, f of x plus h times g of x, but then you add it back on again, f of x plus h times g of x, and then the last term that we have up top here is minus f of x, g of x. Okay, and all of that is still over h. Okay, now I'm going to break this up into two fractions that are added together. Limit as h goes to 0. The first fraction has f of x plus h, g of x plus h, minus f of x plus h, g of x over h, and then plus the limit as h goes to 0 of f of x plus h, g of x minus f of x, g of x over h. And again, you might want to just, look at the step I sort of skipped there. Take this original quotient up here, break it up into two fractions, and then the limit of a sum is the sum of the limits. Okay. For this first term here, I see a common f of x plus h, and I'm going to factor that out. I have the limit as h goes to 0 of f of x plus h Okay, so that is now going to be times, let's see if I can do this with maybe braces so that I can sort of keep track of what's going on. F of x plus h, I'm factoring this out. And I have g of x plus h minus g of x over h. Okay. Is that the way I want to write that? That looks a little awkward. I guess I don't need this, these braces here. Just trying to make the notation look reasonable. Okay, so if I want the limit of a product, the first factor is f of x plus h. And the second factor is g of x plus h minus g of x. So that's okay. And we'll do the same thing with the second term. H goes to 0. We'll factor out the g of x, and we have f of x plus h minus f of x over h. Right? Okay, for both of these, this is a product, and the limit of a product is the product of the limits. So we have the limit, h goes to 0, of f of x plus h times the limit as h goes to 0 of g of x plus h minus g of x over h, plus the limit as h goes to 0 of g of x times the limit as h goes to 0 of f of x plus h minus f of x over h. Okay. Now, let's clean these up a little bit. H is my variable in this first factor. So if h goes to 0, this simply becomes f of x. By definition, again, look at the definition of a derivative. This is g prime of x. This now, notice that h is the thing that's changing, but this expression does not have an h in it. So g of x remains g of x. Doesn't matter that h goes away. There's no h in the expression, so we don't have to worry about that. And by definition, this is f prime of x. Okay, and that's exactly what we were supposed to show. So we are finished with this proof, QED. There's another version in your textbook. You might want to look at that. And there are other versions of the proof of the product rule floating around. I sort of like this one. It's a little tricky there in the middle. You add, subtract and add the same quantity. Okay, let me stop this one here. I